Okay, so this is 2012 question 2. This is an area and volume problem. Just skimming through this, I noticed the words area, cross sections, volume. So I know it's an area and volume problem here, okay? It is question number 2, so we know it's a calculator active problem. But here we go. We'll start it off here. In part A, they're asking us to find the area of R, which is the region that's in between these two functions here, bounded by the x-axis, okay? So we want to know the area between those functions and the x-axis there, okay? So this one here is a little bit tricky because you actually do have options. Normally, most of the time, we would want to integrate in terms of x. If you notice our two functions here, they're already in terms of x. So naturally, we would want to have a vertical rectangle in this case. But notice how there's really no top minus the bottom here. We have a top function, but that bottom function is really just 0 because it's the x-axis, okay? But if you notice, if you move towards the right, the top function right now is that natural log of x. But notice how if you keep moving that rectangle towards the right, eventually at some moment, that is no longer the top function. It actually becomes the 5 minus x function. So it does get tricky here if you're integrating in x because you actually have to set up two different integrals because your top function does change. So that's the first option here, okay? So I'll show you that first option now. If we wanted to integrate in terms of x, we would want to integrate the natural log of x from 1 all the way to about this point, okay? Now, how do we actually find that? This is where your calculator comes into play, okay? What you're going to do is you're going to graph the natural log of x and 5 minus x there, and you're actually going to find out where they intersect, okay? So once you type this into your graph, y1 and y2, you would want to calculate the intersection. So you would go to second, trace, and instead of finding zeros this time, you're actually going to click on, I believe it's 5, which is to calculate the intersection. They're going to ask you 3 questions, first curve, second curve, and to guess. In this case, since we only have 2 functions, you could just press enter, enter. And because there's only one intersection, we don't even have to guess either. Okay, so we'll press enter, enter, enter. At the bottom, they should give you an intersection here, okay? The scoring guidelines indicate that it's about 3.693. Specifically at that point, but for this problem here, we would only need to use the x coordinate. So you could decide to write down the x value here, 3.69344, or you could store it by quitting and then pressing that STO button and allocating a variable to it. I'll leave that up to you guys. So here, I'll just call this from 0 to 3.69344. That would just give you the area from 1 all the way to about that dotted line. So everything in purple right there. But notice how that's not the entire region of R. So what we have to do is we're going to have to add some more area to it. We're going to actually have to integrate the second function, 5 minus x, from where we left off, so 3.69344, all the way to about that point right there. That looks like it's landing on 5. Okay? So this is a quick plug and chug. If you look at the scoring guidelines, this is exactly what happened in the second option here. They integrated from 1 to A, and A is actually defined here as 3.69344. Quick plug and chug, you get your answer. Okay? Now, you do have an option. I'll talk about it. I don't know if people will actually do it, but let's talk about it anyways. So if you notice, when you're trying to integrate in terms of x, this causes you to split your area. Okay? Now, if I were to draw a horizontal rectangle, you notice that there's a clear right function and a clear left function. No matter where I am in this region, that right and that left function never changes. Okay? Same thing as if we had a top or bottom function, right? So we could actually integrate this in terms of y. All right? So we would integrate in terms of right minus left. So here, y equals 5 minus x is your right function. Now, if you're doing right minus left, you actually have to integrate with respect to y, which does cause you to manipulate some of your equations so that x is by itself instead of y. In this case, x here is going to equal 5 minus y if you manipulate it. So that's going to be 5 minus y minus your left function. Now, your left function is actually y equals the natural log of x, but if you solve for x, it's really just e to the y. Okay? So if your functions are going to be in terms of y, then your bounds have to be in terms of y as well. So just take a look at your region. Your region starts at a y value of 0, and it goes all the way up to a y value of wherever that intersection point is. So from 0, now if you went back to the intersection here, you actually have to use the y coordinate, 1.30656. Okay, so the pros to this, integrating in terms of y in this case, we're actually allowed to. You only have to set up one integral, but you do have to find different things. You do have to change your equations. Personally, I think integrating in terms of x is easier, even though you have to split the integral. But again, it's really up to you, okay? Part B. They're telling you that you're dealing with cross sections perpendicular to the x-axis. So right away, perpendicular to the x-axis, I know I'm going to integrate in terms of x, okay? They're telling us that each cross section is a square. So let me go ahead and animate that for you guys so that you can kind of see it. So we know we're going to illustrate a vertical rectangle because we're integrating with x, but now each of those slices are going to represent a square. So basically, that height will give you the length of that base here, but remember that you have to actually set up two integrals because your top function does change. Okay, so here you go. You notice that basically it's just the integral of the area of your base. The area of your base, the shape of it is really just a square, so that's just something squared. So if you integrate it in terms of x in part A, part B is not really different. If you notice that it's really just the same thing, but now it has a square. Okay? Now, this is because the cross section is a square. Now, had the cross section been anything else, you would have to use that formula. So just keep that in mind, okay? Here, I don't think they ask you to evaluate, right? But do not evaluate. There you go. So there you go. So like even if you did calculate it, it's really not necessary. So just keep that in mind, okay? Part C. This pops up very often, and people tend to get confused by it. So let me explain this very carefully, okay? They always talk about some type of line. And either they're making a statement that this line will divide the area into two equal parts, or they're asking you, will this line cut it in half? Okay? So in this case, they're talking about a horizontal line. So I'll illustrate that for you guys here. That divides R into two regions of equal area. So I don't necessarily know where it is, but I'm going to draw y equals k right there. And they're saying that R1 and R2 now have equal area. Okay? They want you to write an equation involving integrals to show that it's equal. So first thing you want to do is, if you want to make an equation, you want to use an equal sign. That's what an equation is, okay? So pretty much we want to show what we're animating here. So I want to show that the red is equal to the purple. Okay? I want to show that the red is equal to the purple. Now, here it's set up in a way where integrating with y would be way easier than integrating with x. Okay? So, we're actually going to integrate with y here, because if you look, integrating with x, it gets super complicated because you're going to have a top minus a bottom, and that top switches, that bottom switches constantly. It's just easier to do right minus left. So here we go. When we're integrating right minus left, again, we're going to have 5 minus y minus e to the y dy. Now, if you look at the red region, everything is in terms of y. The only thing you guys really have to remember is the bounds, okay? Remember that we're looking at the y values. The red region starts at a y value of 0, and it goes all the way up to where that blue line is. And that y value is actually k. Now, if you're looking at that purple region, that purple region starts at that k value, okay? And it goes all the way up to where that intersection is, which is about 1.30656. The right minus the left didn't change, so we'll write it like this. And that's basically it. We showed that these two regions have equal area. Let me see if they did anything different here. Okay, so if you look at the scoring guidelines, they did it a little bit differently. They said that from 0 to k, this is pretty much the red region, okay, is going to be equal to half of the entire thing. Okay, 2.986 we got from part A. So they wrote it a little bit differently. They're saying that just the red region is going to be half of the whole region. Okay? You're more than welcome to do that too. I think it's just easier to do this, setting up two integrals, but you do have the option, because it does say use one or more integrals. So I'll leave that up to you guys on which one you want to do there. Okay, that's it.